Hi, and welcome to this short video demonstrating how to generate slices for internal lattice structures without ever creating the full explicit geometry for the complete lattice. If you haven't already watched it, I'd recommend watching the previous video, Multiple Boolean Union, Creating an Internal Lattice, as that demonstrates how you can use Polygonica to create a full geometric mesh representation of an internal lattice structure. And we'll be using the same principles in this demonstration, so it might help to understand what's happening here. As always, you can follow both Polygonica and MachineWorks on LinkedIn, and we'd encourage you to do this. That's the simplest way to stay in touch with new updates, things like code examples, how-to videos like this one, and product announcements, and of course other PR that we're likely to put out. So Polygonica has a number of different slicing operations. First, you can slice a single part or solid or mesh, and we call that solid slicing, and I guess that's probably the most commonly used slicing operation in Polygonica. Of more interest for this demo is what we call world slicing. So the world is, if you like, the entire scene. So it comprises multiple different solids or multiple different parts, and also multiple instances of parts. So you can think of a world as being more like an assembly, for example, in a CAD model. And each of these different instances can have different properties, such as, and in particular, transforms, such as translation, rotation, and scale. And that's a really important concept in this demonstration. So we added the world slicing functionality really to help slice many different parts on a single print tray in one go. And of course it has the benefits that the Polygonica can then use internal multi-threading really heavily to speed things up. But it's also useful for lattice creation, as I'm going to show you. Polygonica also has a wide array of 2D profile operations. So these are really intended for things like generating hatch and infill for build processes. But they're also pretty useful in this case, so we're going to use the 2D Boolean operations pretty heavily in this demo. Okay, so the idea here is to create a cube representing a repeatable lattice unit. The lattice is then defined by transforming instances of this cube in X, Y, and Z to create a cuboid definition or representation of the lattice that completely fills the part. So in the previous video I referred to, we showed you how we could use 3D Booleans to quickly take that instance representation and create the explicit representation of the lattice. In this demo, we never do that. We never actually create the full geometry. What we're going to do is just use world slicing to slice the instances that define the lattice using that repeated unit cube. So in the picture on the left, bottom left, you can see a gyroid mesh that I basically just created using an online gyroid generation tool. And then on the right are the slices that I've generated using world slicing by instancing that mesh in an 8x8x8 cube. So at no point is the full mesh ever generated. So obviously it's much faster. I'm just able to slice each instance in the world at its location and scale and rotation, or Polygonica is able to do that. However, once we've generated the lattice slices, we need to clip them to the part and then union the clipped lattice to the part. And we do that using the 2D Boolean operations. So the picture on the left shows the unclipped lattice slices from before, whilst the picture on the center shows a sphere. So we've created a sphere to represent the part in this case, keep it simple, and we've hollowed out the sphere and then sliced the sphere. And then each slice in the lattice is first clipped to the corresponding slice from the sphere, and then the resulting clipped slice is unioned to the same slice from the sphere to create a full slice representing one layer of the final part. So the image on the right shows what this would look like if we actually created the full explicit mesh geometry of the sphere that we're showing in the center. But as I've said already many times in this introduction, we never actually do that in this demo. We just create the slices without ever creating the lattice itself. Okay, so on to the demo. So the first thing to say is that Polygonica is sold as a software library only with an API. So we don't provide this GUI demonstration program that I'm going to show you this in. It's just something that we develop internally and just use for demonstration purposes. Okay, so I'm going to start off just creating a sphere, and we'll create a lattice in a sphere first of all. I'm going to create, let's say, a grid of 24 by 24 by 24. I'm just going to do 100 slices, a uniform grid, so it's the same grid separation in each axis. And we'll clip that to the sphere. So again, that's obviously, if you created all the mesh geometry for that, it would be quite a lot of mesh geometry. But in this case, we've done that in 1.8 seconds. And you can see the slices, but if I make the sphere transparent, you can see inside, but obviously all we've got is a mesh of polylines. So let me hide the sphere and look at it from the top. Is probably a good view. So if I look at it from the top, you can see there is a grid lattice added inside the sphere. And if we look at the edge, you can see the sphere has been hollowed out. And there's the lattice structure, and the lattice has been unioned into the grid correctly. So what we've got there is, if you printed that part, you would get the correct lattice geometry inside, all unioned to the part. But obviously it's a bit hard to see when you're just looking at polylines. If I look at it from the front, you can see that there's the different slices. But obviously if I look at it from any kind of 3D view, then it looks a bit strange. Okay, so I'm going to try another sphere, and this time we'll do a diamond lattice. Again, 24 with 100 slices. This time I'll create an unclipped version actually. Let's just do that. So it took slightly longer, and you can see this time we didn't clip to the sphere, so you can see the lattice. Again, if I hide the sphere and we'll just look at the cuboid from the top, and this time you can see we've got a nice diamond pattern, and that's actually diamond in a sort of diamond shape in 3D, which is why you can see these small circles in the middle, because actually there's diagonal beams going down through space. So I'll do that again and just create a clipped version of it, just so you can see that. So slices clipped, go to 24, and again you can see it's pretty quick to do this. It'll take a bit longer this time because it has to do the clipping and also the unioning. Again, let's get rid of the sphere itself and look at that from the top. So here we can see the diamond pattern and the fact that it's clipped to the hollowed out solid on the edge. Okay, so we'll try now with a couple of, I say, real parts. Let's use good old 3D Benchy, which is really nice for these simple demonstrations. And I'm going to do a diamond lattice again. And let's do that. This will take a bit longer. I'll make sure I do slices. Yep, off we go. So it's got a bit more work to do here because there's more clipping, there's more surfaces to clip to and union to. So yeah, on each layer of slice there's a bit more work, because this model's quite nice because there's lots of internal, there's lots of small voids inside the model. It's not just a big uniform space. Okay, so that took about 27 seconds. So I've actually created two copies here. So this one I've just put a sphere in the center to give my mouse something to rotate around, because we don't select these profiles in this demo. But if I show you it, this is the actual original window and model I was showing you. You can see the slices. But if let's look at them side by side. And again, view that from the top is probably a good idea. So you can see, if I make that transparent and zoom in, you can see we've got the diamond pattern throughout, and we've got slices on all the walls, etc., where it's been hollowed out. So we've got a full correct model there. Again, if I hide the geometry, you can see that that's correct. Okay, so I'll do one more using a gyroid and a slightly, let's have a look, gear knob. Yeah, let's try that. So here we've got a gear knob model, and you can see, as is typical here, all these funny colours show that the model is actually badly oriented, has open edges, it's not stitched together, etc. If I turn on back face rendering, you can see some of these faces exist, but they're oriented incorrectly. Fairly typical CAD, stuff you get from CAD surfaces, but thanks to Polygonica we can heal that, in less than a second. So we've now got a closed solid model, which is great and much easier to work with. And I'm going to load in a gyroid, that gyroid I showed you in the demonstration. So let's load that in as the tool first of all. So it's quite small, the scale is different, but you can just see that gyroid cube in the middle of the model there. So I'm just using that as the base geometry in which to instance to fill this big void inside this this gear knob. So let's do that now. So tool, repeater. There's more density of meshes, polygons in the gyroid, so I'm only going to do it 16, 16, 16. And let's do that. So again, this should take, I don't know, 20, 30 seconds possibly. So again, it's hollowing out the gear knob, it's slicing the result, it's creating the lattice and slicing the lattice, clipping the lattice and then unioning them together. So again, if I just show you those windows side by side, there we go. It's better. So on the right you've got just the lattices, and obviously it's pretty dense because it's a gyroid. On the left you've got the slicing merged with the gear knob. I mean, the orientation means that the top is here. So let's just look from the top, and if we zoom in, we can see the nice sort of gyroid sort of pattern there. So I've got that transparent. Turn off render both sides. If I just hide the model, you can see that they're basically the same things there. So there we go. How long did that take? 17 seconds. Okay, it was only 100 slices. But you get the idea that you can create these pretty dense, heavy lattice infills without ever creating the explicit geometry, which is, I would imagine, quite useful. So in the next video we're going to go a bit further with this and demonstrate the 3MF beam lattice interface. So we'll show you how we can load in parametric lattices from the beam lattice and do various things with them, and also create lattices and save them out to the beam lattice interface in 3MF. Okay, so thanks for listening. If you got any questions, you can get in touch with us via LinkedIn, or you can get in touch with us via the forms on the website. So there's a submit a question form or get in touch form on the website. And please don't be shy. We love hearing from people. And thanks for your time today.